What's going on, guys? Tonight we're out in the shop. We got a machining project we got to do. We've got some pins that we need to build for some pans that go in the top of an evaporator. So we are going to have to cut these down to length. We've got a radius head that goes on the top that the pan slides down on top of. And then we've got to machine a 3/16 shoulder on the bottom so that it can drop down in a hole and get TIG welded on the bottom. These should be pretty quick, pretty simple. We are going to have to machine the top head down that's got the radius on it. I ordered some tooling today to make the radius because I didn't have any. We're going to see if we can't get these knocked out. Let's get after it. Okay, so we've got 6 of these to build. We got to cut them at 4 5/8. Okay, so here's what we got. We got some 3/4 3/16 stainless rod. I'll show you guys the print. This is a piece of 3/4 rod. It's got a shoulder machined in the top of it, and then we have to radius this. So I've got the tooling on its way for that. And then we got to have a little bit of a shoulder down here machined, just 3/16 of an inch, so that they can drop this into the pan. There's a hole in the pan. They'll drop this into the pan, and then they'll TIG weld the backside, just to hold it in place. And then there's a pan that slips over the top of this and it sets on top of it. So we've got our 6 pieces of 3/4 rod cut here. We're gonna see if we can't get these machined at least to the point where we've got to radius them. So see what we can get done. Okay, so we're going to face this off, and then we will cut our shoulder. We got to have a 1/2 inch shoulder. Let's face this off first. I'm going to get some safety glasses on. Okay, so we'll touch off. Okay, so we're faced off there. Maybe they're over here. That's why you put stuff away, so you know where it's at. Okay, so you want to make sure you zero that. I'm getting zeroed. Now, here's how I like to do it. I'll take and mark 1/2 inch on my calipers here, and then I lock it. Then I'll turn my lathe on, and then I'll go ahead and just scribe a mark where I need to cut to. Hopefully you guys can see that mark. There is a mark there. So now I know where I'm supposed to go. We're going to try 30 thou. I'm going to zero this. You can see I've taken and zeroed my dial. So now I'm going to take and go in. So now I'm going to take and go in 30 thou. And there's 30. Go another 40. Another 40. start checking my measurement now. So we got about 110 thou to go. So I'm going to go 2 more passes of 40 and then check it again. Okay, so we are about 38 thou long. So we got to take 38 thou off this end. Okay, so now I want to check. About 15 thou. Whew. Right on the money. 5625. So now that we've got our overall length cut, we need a shoulder that is 3/16 deep. Okay, so I'm going to go 3/16 on the shoulder. Same thing, I'm just going to scribe a mark. Okay, 1875. Okay, and we're going to go half on the diameter of this shoulder too, on the smaller piece. We'll go one more, I'm going to check it. About 95 thou to go. I'm going to switch tools because this has a lot sharper radius on it, so I can get in that corner a little better. Okay, 40 thou. You can see how much sharper that shoulder is now. Touch off, we'll go another 40. Okay, and then we'll check. We got 7 thou. 7 thou to take off. Okay. We're looking good on our depth this way. And then as far as our diameter, probably going to take one more pass there because it's about 2 thou over. And it'd be better if it was like 2 thou under. Okay, that's right on the money. Gonna clean this up a little bit. Let's go ahead and chamfer those corners. Just our regular square insert. So there's our shoulder. And then for some reason this has some sort of gunk all over it from the place I bought it from. So I tried hitting it with some brake cleaner and it comes off, but it takes some elbow grease. So I'm just going to use some emery cloth, clean this up, make the finish match so it looks nice. Looks a lot better. So now I'm going to flip it around. Do the same thing here. Okay.
It's time for today's super cool tool.
Alright, so for today's super cool tool, we're talking about the lathe. And we'll just kind of go through some of the controls and stuff on the lathe. These types of lathes, these smaller tool room lathes, no matter what kind of lathe you're running, the controls are pretty generic. It's a lot like a milling machine. So no matter what the brand is, if you know how to run a lathe, you can typically walk your way through where the controls are. They might be a little bit different, but for the most part, they're pretty close. I will show you guys a picture of the parts of a lathe, and it will just break down what all the parts are. You got your tailstock here. This section is your headstock. This is your chuck, and it connects to the spindle. Your gearing is all right here, and your controls. You've got a jog button here, your e-stop. This one does have a coolant pump. I haven't ran it yet, but the switch is usually going to be somewhere by the controls. It has a foot brake. I prefer a lathe that has a foot brake just for safety's sake. If you do run into a situation where something sketchy's going on, you can tap that or slam your foot on it and it will stop the lathe right now. The other thing it's good for, and the reason I like it, is sometimes when you're threading, it feels like you're on a runaway freight train because it's in gear and it's traveling, and the only way to stop it is to pull it out of gear. But sometimes there's so many knobs and so much going on that you get jittered, and I've had multiple times where there's sketchy stuff going on to where you just want to stop the machine, and all you have to do is put your foot on that, and it's connected to a contactor in the controls where it will stop the machine. The brake stops the machine, and the contactor trips, so it shuts the power off to the machine. And then you have to reset it by taking it out of gear and then putting it back in gear. So that's one feature that I personally do like on a tool room lathe. That was one of the things that I was looking for when I was in the market for one. This is called a quick change tool post. And so you just flip this knob and it has like a dovetail right here. And then you take these, and this tool holder has a dovetail on it. And you just tighten these set screws down on each individual tool. And I'll show you my tooling here in a second. But you can just grab a tool, slip it on the dovetail, pull that closed, and it locks it down, and then you're running again. Okay, so here's a look at some of the lathe tooling. You can see each one of these has the dovetail that slips onto the quick change tool post. The more of these you have, the more convenient it is, because you can take your tooling here, tighten down these set screws, and then when it comes time to change your tools, you just pop that in and swing your knob over and you're rolling again. So there's all kinds of different tooling here. Obviously these type, this right here is a right hand threading tool. This is a right hand facing tool or cutting tool. You've got grooving tools here. That's a grooving tool. This is actually a parting tool to where you can cut a piece of material off. There's our radius tool. This is a left hand threading tool. This tool here is about one of the coolest tools that you can use on the lathe. This tool here is called a knurling tool. If you don't know what knurling is, there's a lot of different types of knurling tools. This is another knurling tool. Knurling is where it puts a pattern on the metal like this so that it's kind of grippy, I guess you'd say. That's a hammer that I completely built on the lathe. These brass faces, you can unscrew those, and then when they wear out, I'll just build some more. Screw those in. And then you have, obviously, boring bars. I have internal threading boring bars. So there's just all different kinds. Right hand, left hand, radius tools. As you can tell, I do prefer indexable tools, which is what these are, because you can just change this carbide insert out. You can actually rotate it 3 times and then flip it over and rotate it 3 times again on this one. The only downside to indexable tools is then you have your carbide inserts, and there's multiple kinds, hundreds of thousands of different kinds, different types of carbide material for different types of metal, and they are expensive. Typically they run between $10 and $20 a piece. They are expensive, but they do hold up a lot better. So that is definitely one of the benefits. So that's your tool post. This is your compound. This is your carriage. These right here, these rails that the carriage rides on, those are called the ways. You want to take care of the ways because the precision that you have in your lathe where the carriage slides, it all rides on your ways. So you want to make sure you take care of those, keep them oiled up. I like to clean mine on a regular basis. I keep one of these lathe brushes, machining brushes on the lathe, and I'll brush the chips off quite regularly. You got your chip pan down here where your chips fall into. This cover comes off so you can clean it out. This is your DRO, which stands for digital readout. I think that's pretty much the basic controls and makeup of a lathe. Something else I'd like to talk about is what you can do on a lathe. So pretty much anything that is round that you can fit in the chuck, you can machine. That's where a lathe is useful. Anything that's round, and even square things. You can put a 4-jaw chuck in this, and then you can machine a round hole into a square part. There are a lot of situations where you can use a lathe or a mill for certain projects, but honestly, if you can get it in the lathe, I do feel like the machining is a little bit quicker and a little less tedious depending on what you're doing. One of the coolest things that a lathe does is it cuts threads. And there's plenty of videos on YouTube that will walk you through how to thread. So I think that's about it on the lathe. This definitely is one of my favorite tools to run. It is very dangerous, but as long as you respect it and you make sure to pay attention where your hands are and make sure to wear your safety glasses, you'll be fine. Whenever you're running any kind of tool, I would just say respect it and know what your risks are and try to avoid those risks. Okay, so that's going to wrap up today's super cool tool. Let's get back to the video. All that's left to do on this one is chamfer our corners. The only reason I need to chamfer this corner right now is so I don't cut myself when I'm handling it until my new tooling gets here. Okay, there's one complete. That's what we needed. So we've got 5 more to build. Should go a lot quicker now that we got a pattern down and we know all our measurements. Let's do it. Okay, so we lost audio on this part, so I'm just going to walk you guys through what was going on. First, I dropped my wrench there, and now I'm getting the new tooling tightened down. This is a 3/8 radius tool. So I got that put in the tool holder, and then fired the lathe back up. When you're using one of these radius tools, you want to make sure that you slow down the lathe, and you want to make sure that you keep your feed consistent, and you also want to keep it oiled up. And you can see it was cutting pretty smooth here. It doesn't take very long to cut that material off when you adjust the lathe correctly and keep it oiled up. Okay, so once the cutting was done, went ahead and took a piece of the shop towel, wiped the oil off, got it all cleaned up. Then I grabbed a piece of emery cloth and just blended the finish, kind of smoothed it up just a little bit. And then that would wrap it up. Got our 5 pins done. They're all consistent. I'm happy with the way they turned out. So that's the 5 that are this way. It's getting pretty late, so I think I'm going to call it a night. Probably going to come back out and get after it early in the morning and see if I can't get that threaded pin done before football. So see you in the morning. Good morning, guys. We're back out here. We are going to see if we can't get this last pin knocked out. So we're going to go over to the saw. We're going to have to cut a piece that's a little bit longer so that we have some extra material to thread, so that when we drop it in the pan, there's more meat there. I was a little worried about having enough material to thread and enough material to make it rigid. So we're going to make it a little bit longer, and we'll just end up tacking a nut on the back side of the hole, on the back side of the pan, and then I'll probably just run a tap up through that, and then I'll cut the threads in the actual pan material, but it'll match up because I'll go from the back side up. So I think we're going to see if we can't get this done. We got football in a couple hours, so let's see what we can do. About 53 thou left to go. Beauty. 15 thou. We gotta go 15 thou deeper. Okay. Okay, we got about 53 thousandths to go. 625 right on the money. Alright, so now we're good this way. 1/2 inch. We're good this way, 625. So I think we're ready to cut our relief. I'm going to use this groove tool to cut my relief. You want to slow it down when you're using these and keep it oiled up, because it will chatter if you don't. So we're just going to go right up against that shoulder and just cut a relief the width of the tool. I'm going to adjust my speed here. Okay, so you got a right-handed and a left-handed threading tool. This tool here is a right-handed. This one's made for threading from the right to the left. So that's a right-handed. I also have a left-handed. You need to use a left-handed when you're cutting left-handed threads. So we'll get this set up here. I always like to make sure I'm set to the apex of the material I'm cutting. Okay, so when we cut this, we'll put it in gear and we'll cut that way. I'll see if I can't get the camera set up a little better so you guys can see what I'm doing. Okay, we're going to get this set up here. So we know we've got to be 13 threads per inch. So there's our 13 threads per inch. So we're going to be number 7. So we've got to change that to number 7. That unlocks it. That locks it back in gear, so we're in number 7. And then we've got to be AC. Okay, so we need to change this. Sometimes you got to turn the chuck a little bit to get that to go in gear. So we're in A, and then we need to be in C. So this is going to set us up for threading so that it runs our lead screw. Okay, there it goes. Okay, that should get us. Let's engage the lathe. Okay, so see how your lead screw is spinning? Now you know that you're in gear to thread. When you're threading, you want to set your compound to 30 degrees. And then you actually want to make your adjustments on how much you're cutting with your compound. You technically don't want to use this. You want to use this. So I always like to run a scratch pass first just to make sure it's running right. And make sure that our threads per inch is correct and that I didn't get something set up wrong. So we're going to go ahead and bring this over. And we will touch off. Okay, that's touched off. Then we got to go ahead and zero this. This is kind of tricky. Okay, got that zeroed. We want to zero this. Okay. So then what we'll do is we'll take this in 5 thousandths. There's a little lash there, so I'm gonna reset 0. Run it in 5 thousandths, okay? I just like to pick the same number when I'm running this thread dial. So I'll just pick number 1 and then I'll engage it. Okay. Okay, and then I stop it when I get to my relief. Okay, so you can see, hopefully, that we've got a scratch pass in that. Okay, hopefully you can see that scratch pass. Okay, there's 13 threads per inch, and then what I'll do is I'll set that in my scratch marks, and that's right on the money. Okay, so now it's just time to thread it. So what we'll do is we can continue where we're at now. What we'll do is we'll go back to 0 here. Once we're there, then we can go in another 5 thousandths, and then you just cut it 5 thousandths at a time. You just go nice and slow, and you just gradually develop the threads. Let's see what we can do. Okay, we're back to 0. Go another 5 thou. Keep it nice and oiled up. Engage it on 1 on the thread dial. Okay, same thing, back to 0. 5 thou. Engage it on 1. A little tight there at the end. I'm going to grab a wrench and see if I can't coax that into going in a little bit further. Sometimes you just get a rough spot in there and you need to just show it a little love. Okay, that's looking good. It's going to put our threads coming right out the end, 3/16 where the pan is going to be. We'll take and TIG weld the nut, stainless nut, to the bottom side of the pan. We should be good. So now the only thing that's left to do, I'll just take my square insert that looks like this that I use for chamfering, and then I'll go ahead and throw that in, and I'll chamfer this corner a little bit, and I'll chamfer the end of the threads, and then I might have to touch that up with a file just so it starts nice. It's probably going to be the last little bit, and then this one will be done. Okay, another little safety tip for you guys. If you're using a file while you're running a lathe, you really want to try to have a handle on this. If you don't have a handle, do not put it in the palm of your hand like this, because then when you are filing, if it snags or hits, it'll jam the end of this file into your hand. So you want to make sure when you're using it, if it doesn't have a handle, and ultimately you should have a handle, but if you don't have a handle for that size of file, make sure that it is past your palm so that if it hits, it'll slide through your hand. I know someone who ran a file through their hand, so. Alright, we went ahead and cleaned our threads up with the file. Got a 1/2 inch nut here. Okay, it's going to be about perfect. Okay, so all that's left to do, I'm going to hit this with some emery cloth, make the shine match, and give you guys a look at the whole thing. Okay, so here's our pins. Got them all complete. Got 5 with the shoulder that just drops into the hole drilled in the pan, and then we'll TIG weld it up on the back side. Top's nice and rounded so that the pan that sits on top of the pin drops right in. We did have one specialty pin we had to machine with threads that'll screw into a 1/2 inch nut that we're going to TIG weld on the back of the pan. The height will be exactly the same, but this one they'll be able to remove when they need to clean the equipment. So that's going to wrap this one up. Appreciate you guys watching. Feel free to comment, like, subscribe, and share, and see you on the next one. So here's our print. So basically it's just a piece of 3/4 rod, but it's got a shoulder machined, and then we have to radio, but it's got a shoulder. So here's what we got. It's a piece of 3/4 rod. It's got a shoulder machined on it, and then we have to radio that. Okay, so for today's super cool tool, we're going to be talking about the lathe. So a lathe is definitely one of those specialized tools, but it has a lot of uses that can help you with very specified, very specific things. Okay, so today we're talking about the lathe. And a lathe is so I think that's about it on the lathe, which is digital readout. This is your DRO, this is your DRO, which stands for. There is a lot going on, and you just kind of have to keep straight what you're doing and try to keep yourself safe and make sure that you slow it down. I think if one of the coolest things that a lathe does is it cuts threads. One of the coolest things, as long as you can figure out how to figure out, I think I'm going to call it a night and come out early in the morning and see if I can't get the last one with the threaded end finished tomorrow. Have to get up early and come out here and see if I can get it knocked out before I got football. So it's getting pretty late, so I think I'm going to